Hello, this video is on lesson 7-2 and it begins on page 107. The learning target here is to factor quadratic expressions of the form ax squared plus bx plus c. This is a very important lesson because factoring quadratic expressions is something that we're going to be doing continually for the rest of the Algebra 2 course. And so it's really important to get a very good understanding of how to factor quadratic expressions. So in order to get a really good understanding, let's go all the way back to elementary school and find what the area of this square is. Very simple. It's going to be 100. How do we get 100? Well, you basically multiply the length, which is 10, times the width. So length times width gives you 100. Okay. What if we have this right here? Well, there's actually two different ways we can find the area of this square or rectangular shape. So what we can do is do the same thing that we just did, is to multiply the length, but notice the length consists of 4 and 2, so we need to add those together. And so in one parenthesis we have 4 plus 2, which is equal to 6. And when we take a look at the width also contains the dimensions of 4 and 2, which we have to add together to give us the width. And so when we have 4 plus 2 times 4 plus 2, which is basically length times width, it's basically 6 times 6, which is 36. Same thing that we did here, multiply length times width. But there's a different way we can calculate the area, is by calculating the area of each individual shape. Here's what I mean. If we want to find the area of the red shape, basically the dimensions are 4 by 4. So the area is basically 4 times 4, which is 16. If I want to calculate the area of this blue shape right here, I know that its width is 2 and its length, this length right here, is actually 4. So 4 times 2, that gives me 8. If I wanted to find the area of this other blue shape here, this has a length of 2, and if we look at the width is actually 4. And so 2 times 4 gives me 8. And finally, this green area right here has a length of 2 and a width of 2. So 2 times 2 gives me 4. Now, to find the area of the rectangular shape, we simply have to add the areas together. So we have 16. Notice that the blue areas are both the same. So 8 plus 8 is 16, plus the area of the green shape, which is 4. When we add these together, 16 plus 16 gives me 32, plus 4 gives me 36. And so we can see that adding the individual areas together gives me the same area as multiplying the length and the width of the rectangular shape. So we both get 36 units. Now let's take a look at this example here. Again, what we can do first is multiply the length and the width. And notice that the length is x plus 6 and the width is going to be x plus 6. And so if I multiply those together, that gives me the area of the rectangular shape. But I can also go ahead and find the area of each individual shape here. So if I wanted to find the area of the red shape here, I have a length of x and a width of x. X times x gives me x squared. This blue rectangular shape here has a length of x and a width of 6. 6 times x gives me 6x. Here, this blue rectangular shape has a width of x and a length of 6. Multiply those together, that gives me 6x. And this green shape right here has dimensions of 6 by 6, which is 36. Now when I go ahead and add these individual areas together, I get x squared. And I also want to go ahead and combine like terms here. So 6x plus 6x is going to be 12x plus 36. Now take a look at that. The areas can be calculated in two different ways, and so it seems like we have two different expressions. We have that the area can equal x squared plus 12x plus 36, or it can equal to parentheses x plus 6 and another parentheses x plus 6, multiplying them together. So how do we know for sure that these two expressions on either side of the equal sign are actually the same thing? Well, here's what we can do. We can go ahead and take x plus 6 and x plus 6 and use distribution to see what we get. Alright, so let's take a look at this. X times x. So first we need to distribute the x. So x times x gives me x squared. X times 6 gives me 6x. Alright, now we have to distribute the 6. So here we have 6 times x, which is 6x. And then 6 times 6, which gives me 36. Now when I combine like terms, I get x squared, 6 plus 6x, 6x plus 6x gives me 12x plus 36. Take a look at this. It's exactly the same thing that I get here. So in fact, these two expressions are the same thing and the equation is true. Okay. So now that we have an idea of how to set up the equations, let's just go ahead and find the two different expressions for the area of this rectangular shape. 3x times x, that gives me 3x squared. 5 times x gives me 5x. Here I have 3x times 1, which is just 3x, and then I have 5. So if I want to write the area for this, it's going to be 3x squared. 3x plus 5x gives me 8x plus 5. Now to get the other expression for the area, we're always going to have two parentheses, and you basically get them from here. So we get 3x plus 5 and then x plus 1. It does not matter which order you put them in. You could have had x plus 1 times 3x plus 5. Alright, let's do the other one. We have one more example. Again, we want to multiply the areas of each individual shape. So we have 2x times 3x, which is 6x squared. 3x times negative 9, which is negative 27x. 4 times 2x, which is 8x. And then 4 times negative 9, which I believe is negative 36. Okay. Let's go ahead and put the areas, add the areas up. Here we have negative 27x plus 8x. That's going to be negative 19x and then minus 36. And to get the other side, we just basically put these in parentheses. So notice we have 2x minus 9. And then here we have 3x plus 4. Now again, how do I know that this is equal to this? Well, you can just go ahead and distribute this to verify that they are in fact equal to each other, which is what we did here. Alright. So we have an idea of how to write the area of this shape in two different forms. Notice that this form is in the form of ax squared plus bx plus c. That is the the standard form of the quadratic equation. So we see it here again. Now here is the main question of the lesson. What if, instead of starting off with these dimensions in order to find the area, what if instead we are given this equation here, the standard form of the quadratic formula, and what we want to do is find what are the two parentheses that go in each one. How am I going to find what goes inside those parentheses? Well, we can go ahead and take a look at the previous two problems that we just did. So take a look at these. And notice that we always take this 3x squared and we put it into the first red box. And so we can go ahead and do that. So this is going to be 6x squared. Same thing that we did here. We took 6x squared, put it right there. And notice that my constant, the number that doesn't have any variables, is called a constant. The constant goes inside the green box. And so here my constant is negative 36, and that goes inside the green box. So that's what I'm going to do with my negative 5. Negative 5 goes in the green box. Okay. But here is the key. This 8x, how did I know to break it up into 3x plus 5x? Well, 3x plus 5x gives me 8x, but how did I know how to break up 8x into those two numbers, those two expressions? Same thing with the negative 19x. Negative 19x, how do I know to break that up into these two expressions? Well, I know that negative 27x and 8x gives me 19x, negative 19x, but I could have used many different other combinations. So that is the main question of this question right here. How do I know what to break up 13x so that I know what goes in each blue area? Okay. So let's go ahead and find out how this is done. So the way that we find out is, first of all, we have to look at the standard form, which is ax squared plus bx plus c. And what we need to do, and this is going to be the same for any quadratic equation, so it's going to work for this, it's going to work for this one, it's going to work for that one, for any quadratic equation. So what we need to do is we need to take the coefficient of x squared. Here's x squared. The coefficient is a number beside x squared. In this case, my number is 3. So I'm going to take the coefficient of x squared, which is 3 in this quadratic equation, and multiply it by the constant, which is, in this case, is 5. So 3 times 5, and multiply them together, and that gives me 15. Same thing I want to do here. I want to take my coefficient of x squared, which is, in this case, is 6, times my constant, which is negative 36. Alright, so let's go ahead and multiply those together. 6 times negative 36. And that is going to be 216. Okay. Alright, so let's do the same thing here. Let's go ahead and take my coefficient of x squared, which is 6, and multiply it by my constant, which is negative 5. And what I get is going to be negative 30. Okay, so we multiplied the coefficient of x squared and multiplied by the constant. Okay, so what do we do after that? What we do now is we basically find all the different factors, pairs of factors that we can think of. So 15, well, the obvious one is going to be 1 times 15, but you also have 3 times 5, and that's basically it. What about 216? Well, this is negative 216. Alright, so the obvious easy one to come up with is negative 1 and 216. Negative 2, we'll probably have to use a calculator for that. 216 divided by 2 is 108. Can we divide it by 3? 216 divided by 3, that's going to be 72, so negative 3 and 72. And you want to keep on doing this until you can find all of them. So 216 divided by 4, 4, negative 4 and 54. 216 divided by 6, 6 and 36. And 216 divided by 7 doesn't come out to an even number, so let's just skip to 8, 8 and 27. Okay, I think we have enough there. So let's go ahead and do the same thing with this one right here. So notice that we do have negative 30. Now, I decide to make that 1 negative, but for this moment it doesn't matter which one you pick. So we'll just keep making the first numbers negative. So negative 2 times 15 gives me negative 30. Negative 3 times 10 also gives me negative 30. Negative 5 times 6 also gives me negative 30. Okay. Alright, so we found the factors. What do we do now? Here's the key. Here's the key. What you want to do is you want to find which factors, when you add them together, give you the coefficient of x, which in this case is 8, and in this case it's negative 19. So let's take a look at the first one. Which of these, when I add them together, give me 8? So 1 plus 15, well, that gives me 16. Not what I'm looking for, but take a look at this. 3 plus 5 gives me 8. This is exactly what I'm looking for. And take a look. This 3, since these are the pairs of factors that give me, that are the factors of 15 and that add up to 8, these are exactly the numbers that go inside my boxes. All we have to do is just put an x next to them, the variable that you're using, and that is how you know how to break them up. Exactly. Now, how do I know to put the 3 here and the 5x here? It doesn't matter. We could have put the 5x here and then the 3x there. You're still going to get the same answer. And I'll show you an example of why it is still the same answer. But let's take a look at this one right here. This is always going to work. And so let's see here. What I want to do is find the factors of negative 216 that add up to give me negative 19. Alright, let's see. So when I add these together, that gives me 215. When I add those together, that gives me 106. Okay, so still not close to negative 19. This one is going to be 69. That's going to be 50. Looks like we're getting closer here. This is going to be 30. Take a look at this one. Negative 8 plus 27 gives me 19. It's very close. But what I'm looking for is negative 19. So negative 8 times 27 does give me negative 216, but couldn't I do this? Instead of having negative 8, I have negative 27 and positive 8. If I multiply those together, does it still give me negative 216? Yes, it does. But now check this out. 8 minus 27 gives me negative 19, which is exactly what I'm looking for. And that is what, so these are the pairs of factors that I'm looking for, and that's what determines what goes inside the blue shaded boxes. Exactly. We just needed to put the x, and that's it. That is exactly how we knew how to split negative 19 apart into these two numbers, and that's how exactly we knew how to split 8 apart into 3 and 5. So this is the process that you have to remember. It's going to be the same process for all of these quadratic equations. So now let's go. Now that we know what to do, let's go ahead and break 13x. So first of all, which of these factors, when I add them together, are going to give me 13x? Alright, so let's add them together. This one gives me 29. When I add these together, that gives me 13. Oh, this is going to be the one right here. Okay, so this is going to be, so now I know how to break them apart. This is going to be negative 2x and then 15x. Negative 2x plus 15x gives me negative 13x. So what I want to do is find what common factors do I have here. What can I take out from both of those? And this is what I am seeing here. So you want to find the greatest common factor. What can I take out from both of those two expressions? Well, what we can do here is break down each of them into their components. 6 can be broken off into 3 times 2, and then x squared is going to be x times x. Alright, 15 can be broken apart into 3 times 5 times x. And so notice all we did was we broke down each expression individually, and now what we want to do is compare these two expressions and see what they both have in common. Take a look at, notice that they both have x and they both have a 3. So what that means is that I can break down, what I can do is factor out 3x from both of those parentheses, from both of those expressions. So that means 3x is going to go outside my parentheses, and whatever is left uncircled, which is 2 and then x, that's going to be 2x plus 5. This is what I mean by factoring, because when I go ahead and distribute the 3x back into the parentheses, we get 3x times 2x, that gives me 6x squared, and then 3x times 5, that gives me 15x, which is exactly what I got in the very beginning. And so 3x is what it breaks down to. So that means that 3x can go here. There, this is the dimension of that red box. So 3x times, so what we want to do now is find the dimension of this. So 3x times what is going to give me 6x squared? Well, that's going to be 2x. So I know 2x is going to be right here. So now that I have this, the rest is actually pretty simple. How do I find the dimension of this? Well, since I know this is 15x, 3x times what is going to give me 15x? Well, that's going to be 5. 5 is going to go right here, because 3x times 5 gives me 15x. And finally, the last thing I need to do is figure out 2x times what here gives me negative 2x. Well, that's obviously going to be negative 1. So negative 1 times 2x gives me negative 2x. And guess what? We finally have our parentheses. We have 3x minus 1 and 2x plus 5. There we go. We just found the other expression that the area is equal to. And let's go ahead and verify this. How do we know this is correct? Let's go ahead and use distribution, 3x minus 1, 2x plus 5. First thing you want to do is multiply the 3x times 2x. That gives me 6x squared. 3x times 5. That gives me 15x. Negative 1 times 2x, negative 2x, and negative 1 times 5, minus 5. Let's combine like terms. So we have 6x squared. 15x minus 2x is 13x minus 5. There you go, ladies and gentlemen. Exactly what we have here. So we have 3x minus 1 and times 2x plus 5. We worked backwards. We started with the quadratic equation and we factored it to get our two parentheses. So that is what we did here. We factored a quadratic expression of the form ax squared plus bx plus c. Now remember when I told you that it didn't matter where we put the negative 2x and the 15x. Now what if instead I put 15x here and negative 2x there? Are we still going to get the same answer? Well, first of all, I need to figure out how am I going to break this apart. Well, in order to do that, you need to find the factors of 6x squared and negative 2x. Going all the way back here, which is this. Same thing that we did here. Let me erase this part right here. What can I take out from 6x squared and negative 2x? Well, to really understand this, I need to break it down. So 6 I can break down as 2 times 3, and then x squared becomes x times x. There we go. That is the same as that. What about negative 2x? Well, that's going to be negative 2 times x. Or to be more specific, negative 1 times 2 times x. Because when I multiply these out, it gives me negative 2x. Alright. Here's what I want to do now. What do they both have in common? So they both have an x in common, and they have a 2 in common as well. So that means that I can write the 2x outside the parentheses, and what I have left over is basically what's left uncircled, which is 3x, and then we have negative 1. There we go. So what I can take out from 6x squared and negative 2x is going to be 2x. I can take out 2x. Since I know this dimension is 2x, then what is the dimension of this? 2x times what gives me 6x squared? Well, this has to be 3x squared. And now the rest is pretty simple. 2x times what gives me negative 2x? Well, that's going to be negative 1. And then 3x squared times what is going to give me 15x? Wait, hold on. This is supposed to be 3x. Okay. 2x times 3x gives me 6x squared. Alright. Okay. 3x times what gives me 15x? Well, that's going to be 5. 3x times 5 gives me 15x. And take a look at this. Here, I had that my expression is 3x minus 1 times 2x plus 5. Here, I have that my expression is 2x plus 5 times 3x minus 1. Are these exactly the same? Yes, they are. They're just switched around. So as you can see, it doesn't matter where we place the 15x and the negative 2x, we are still going to get the same answer. Okay, so let's do another example. And I wanted to show you this number one rule. The first thing you want to do before you factor a quadratic equation is you want to take out the greatest common factor. So in order for this method to work, you have to have the greatest common factor taken out. So in this case, can I take out something from 5, 40, and 75? Yes, I can take out a 5. So you want to factor out the 5, which means I'm going to be left with x squared plus 8x plus 15. Because when I distribute the 15 back, I get 5 times x squared gives me 5x squared. 5 times 8x gives me 40x, and then 5 times 15 should give me 75. Alright, so now that we took out the greatest common factor, what we can do now is concentrate on the quadratic equation, this quadratic equation, and find out what two parentheses is going to be equal to. So, by the way, the method that, okay, before we go to the box method, we need to go through the same steps that we did here. So in order to get these two numbers, we can go ahead and create our box, by the way. Here's my box. And so I know that x squared is going to go right here, and then 15 goes right here. Again, the essential question is, how am I going to get those two numbers right there? How am I going to break down 8 or 8x? How am I going to break that down so that I know what to put in those two boxes? Well, that's the process that you have to remember. We took the coefficient of x squared times the constant, which is here, multiply them together, find the factors, and which of those factors are going to add up to give you that number right there. Alright, so that's what we want to do here. First thing we want to do is we want to take the coefficient of x squared, which is in this case is 1, times the constant, so 1 times 15, which is 15. Now this looks familiar. What are the factors of 15? So factors of 15 are 1 and 5 and 3 times 5. So which of these factors, when I add them together, are going to give me 8? 1 plus 15 is 16. 1 plus 5 gives me 8. These are the two factors. And so those are the numbers that I'm going to put inside my two boxes. But don't forget to put your variable x. They're always going to have that variable with them. Alright, so now I know what goes in those two boxes. What I can do now is go ahead and begin finding the dimensions of this box right here. That's the first thing you want to do. Now guess what? I have 1x squared. What are the two factors that 1x squared can be broken off? Well, it's just going to be x and x. So x goes here, and then x goes right there. Because x times x basically gives me x squared. 1x squared, same thing. Well, that was simple. So now the rest is going to follow simply as well. X times what gives me 5x? Well, that's just going to be 5. And here, x times what gives me 3x? Well, that's simple as well. It's going to be 3. And guess what? The two parentheses that this quadratic expression factors in are x plus 3 and x plus 5. So to write my final answer, remember I took out a 5 at the very beginning, so my final answer is going to be 5 times x plus 3 times x plus 5. There we go. That is it. Okay. So let's do one more example. Here we have something that looks a little bit more different. So the first thing you want to do is take out the greatest common factor. Alright, so what can I take out from both of these? Well, it looks like I can take out a 2. So 2 goes on the outside of the parentheses, and I'm left with x squared minus 144. Because when I distribute back the 2 times x squared gives me 2x squared, and then 2 times 144 gives me negative 188. Alright, so it works out. So what I want to do now is just focus on factoring the inside of the parentheses. But take a look at this. What is missing here? Comparing it with my other ones, it looks like I have my x squared and I have my constant. But what about my coefficient, my x, and the coefficient that goes along with it? Well, it's actually not missing, it's just invisible. What I basically have here is plus 0x minus 144. Think about this. Isn't this expression here the same thing as that? Yes, it is. It's exactly the same thing. And so the reason we want to put it like this is because this is going to help us with factoring it into 2 parentheses. Alright, so let's go ahead and create our box. Right there. There we go. Again, x squared always goes in the top left box, and my constant goes in my bottom right box, which is negative 144. Again, we have to figure out what goes in those 2 boxes. Well, you have to take the coefficient of x squared, which is going to be 1, times the constant, which is negative 144. And you get negative 144. So what are the factors of negative 144 that, in this case, add up to 0? Alright, so let's go ahead and begin. Well, the obvious first one is going to be negative 1 times 144. And then we probably have to use our calculators to do the rest. So we can take 144 divided by 2. So it's going to be negative 2 and 72. Let's continue on. 144 divided by 3. 3 and 48. 144 divided by 4, 4 and 36, negative 4 times 36. And 44 divided by 6, 6 and 24. Now, if you feel like you have a decent amount of them, you can go ahead and begin adding them together to see if you can get 0. But looking at this, the only way you can get 0 is if you basically have the same number but one of them is negative, because this gives me 143, this is going to give me 70, this gives me 45, 32, and 18. We want to get 0, so we still need to keep on finding more factors. There has to be a factor, by the way. let's see, 144 divided by 7. We want to only use whole numbers here, so 144 divided by 8. 8. Negative 8 and 18. Well, when I add those together, that gives me 10. Seems like we're getting closer, though, to 0. 144 divided by 12. Take a look at that. 12 times 12 gives me 144. Let's make one of those negative. So negative 12 times 12 gives me negative 144, and when I add them together, they give me 0, which is exactly what I'm looking for. Alright. So now let's go ahead and put these inside the boxes. Negative 12x and then positive 12x. Again, it doesn't matter which one you put, where you put those at. Now let's go ahead and take a look at the first box. How can I split up x squared? Well, the obviously only ones are going to be x and x. X times x gives you x squared. Very simple. So now all we need to do is figure out x times what gives me 12x. Well, that's going to be 12. X times 12 gives me 12x. X times what gives me negative 12x. Well, that's going to be negative 12. Negative 12 times x gives me negative 12x. And as you can see, 12 times negative 12 gives me negative 144. There we go. There we go. And so now, I guess I can erase that. We can now factor that into two parentheses, and basically these are it. X plus 12 and x minus 12. There we go. Those are my two parentheses right there. And so since at the very beginning we did take out a 2, my final answer is going to be 2 times x plus 12 and x minus 12. There we go. That is it. Now, the method that we've been using to factor quadratic equations, going all the way back to the beginning, the method we've been using to factor quadratic expressions has been the box method. So you can use the box method to factor these, and I very much like the box method. Now, I do want to show you another different technique called grouping. And so what we're going to do, we're going to go through all of the ones that we just did, and instead of using the box method, we're going to use the grouping method. So let's clear that out. And we want to use the grouping method for this. Again, the very first thing that you want to do is see if you can take out any common factors, the greatest common factor. In this case, there's not going to be any. So we have to take, now the grouping method is going to be doing the same thing up to a certain point. So we're going to still be doing the same thing at the very beginning. What you want to do is take out the coefficient of x squared times the constant 6 times negative 5, which gives me negative 30. So notice we're still doing the same thing, and we want to find the factors of negative 30 that add up to 13, and we found that the factors to be 15 and 2, negative 2. Okay. Now, since we aren't using the box method, we're not looking at this anymore. So now that we have our two factors, here's where the grouping method differs. What we're going to do is we're going to bring everything down except 13x. 13x, what I just figured out, can be written as 15x minus 2x, and then bring down -5. As you can see, these two expressions are exactly the same, because 15x minus 2x gives me 13x. Exactly the same thing. Now, here's why we call it the grouping method, because the next thing we do is we put the first two terms in parentheses and then the last two terms in parentheses. And what we want to do is basically factor each parentheses. What do I mean by factoring? Well, basically what we did at the what we did here. And so remember, when we factored 6x squared plus 15x, if you had trouble, we basically broke down 6x squared as 3 times 2 times x, and then 15x as 3 times 5 times x. And then basically figured out what do both of these have in common. Well, basically the 3x and a 3x as well. So the 3x goes on the outside, and whatever is left uncircled, which is 2 and x and 5, goes inside the parentheses. So that means that right here I can take out a 3x, and whatever's left inside is going to be 2x plus 5. Now, how do I know if I did this correct? Well, you can basically just distribute the 3x. 3x times 2x is going to be 6x squared, and then 3x times 5 gives me 15x, which is exactly what I have here. So if those are the same, you know you did it correct. Here, what I want to do is see what can I take out from -2x minus 5. Alright, so let's go ahead and break this one down. So -2x can be broken down as -1 times 2 times x, and then -5 can be broken down as -1 times 5. Let's take a look at what they both have in common. They both have a -1, and that seems like that's it. So that means that my -1 goes outside the parentheses, and whatever's left over is going to be inside. So we have 2x in there, and then we have plus 5. There we go. Now, how do we know if we factor these correctly? Well, here's how you know. These two parentheses must be the same. If they're not, then you have to check again. You have to see what else you need to factor. But in this case, they are the same. So what happens is that these two parentheses combine as 1, 2x plus 5, and whatever's outside goes into my next parentheses, which is 3x minus 1. And there you go. Those are my two parentheses. So instead of using the box method, we can also get the correct answer by using the grouping method, which is what we did here. Alright. My personal preference is the box method. It's very simple, but if you find the grouping method to be more helpful to you, then by all means use this method. Alright, this is lesson 7-2. Thank you for watching.